Hey everyone, in this video we are solving quadratic word problems involving geometry. Our first example, the length of a rectangle is 2 feet longer than its width. Find the dimensions if the area is 63 square feet. So for geometry word problems, I like to draw a picture to visualize what we're dealing with. So we can draw a rectangle, and the length of the rectangle is 2 feet longer than its width. So if we define x to be the width, then x plus 2 would be the length. And we will define that with a let statement. So we'll let x be the width, x plus 2 is the length. And they tell us that the area of this rectangle is 63 square feet. Now to find area of a rectangle, that's length times width. So we can create the equation x times x plus 2 equals 63. Now, we can distribute the x, so x squared plus 2x equals 63. And what we need to recognize is we have a quadratic equation, and in order to solve, we need the equation equal to 0. So we get x squared plus 2x minus 63 equals 0, which now we can factor. So we'd have x plus 9 times x minus 7 equals 0. As 9 and negative 7 are factors of negative 63 that add to positive 2. And by the zero product property, we know that either x plus 9 equals 0 or x minus 7 equals 0. So x equals 9 or x equals 7. Now, based on this word problem, negative 9 does not make sense as an answer because we cannot have a side length of negative 9. Okay, so we reject this answer. So only the answer of x equals 7 is valid. And we're looking for the dimensions. So the dimensions would be 7 feet by 9 feet. Perfect. Next up, in a rectangle, the ratio of the length to the width is 10 to 3. If the area of the rectangle is 120 square inches, find the width. Okay, so again, we have a rectangle. Now they've given us the ratio. So the way to deal with this ratio is create a factor of x, because we don't know that the length and width are 10 and 3 exactly. Maybe it's 20 and 6. Maybe it's 30 and 9. Right? Some multiple where if we reduce, we'd get a ratio of 10 to 3. So we can define the width as 3x and the length as 10x. Okay, so we'll define our let statement. So let 3x be equal to the width, 10x will be the length. Let's rewrite that. That looks messy. Be the length. So they've given us the area of 120 square inches. So the product of the length and the width, so we'll go 3x times 10x, that is 120. So simplifying, we'd have 30x squared equals 120. So we can divide both sides by 30, and we have x squared equals 4. Now again, we have a quadratic equation that we're looking to solve, so let's set it equal to 0. So x squared minus 4 equals 0. We can factor using the difference of two squares. X minus 2 times x plus 2 equals 0. So we know that either x minus 2 equals 0 or x plus 2 equals 0. So either x equals 2 or x equals negative 2. Based on the word problem, the negative solution does not make sense. We would reject that answer based on the context. So again, we're looking for what? All right, we're looking for just the width. So if x is 2, then the width is going to be 3 times 2, which is 6 inches. Okay, on to the next one. The length of a rectangular field is 7 less than twice the width. the area of the field is 640 square meters. Determine to the nearest tenth the dimensions of the field. So we have our field. The length of the rectangular field is 7 less than twice the width. So if we define x to be the width, 7 less than twice the width would be 2x minus 7. So we let x be the width, and 2x minus 7 is our length. The area is 640 square meters, so our equation would be x times 2x minus 7 equals 640. We'll begin by distributing the x, so 2x squared minus 7x equals 640. We have a quadratic equation, so 2x squared minus 7x minus 640 is equal to 0. Now they told us to the nearest tenth. So what that tells me is we can't factor this. We're going to have to use the quadratic formula. Well, if that's the case, we might as well check the discriminant anyway to confirm that, and then we can proceed with the quadratic formula if we can't factor. So here we'd have a equals 2, b equals negative 7, c equals negative 640. So our discriminant then is going to be negative 7 squared minus 4 times 2 times negative 640. So we'd have, let's go to the calculator. So 4 times 2 times 640. So that's 5,120. So we have 49 plus 5,120. So that's going to be 5,169. Which, just doing a quick check, taking the square root of 5,169, hitting enter, it's not a perfect square, which should not be a surprise. So now we're going to use the quadratic formula. So that's going to be x equals negative b, so the negation of negative 7, plus or minus the square root of our discriminant, 5,169, all over 2a. Now the nice part about rounding to the nearest tenth is we don't have to worry about simplifying our square root here. We're going to be plugging into the calculator anyway. So we have x equals positive 7 plus or minus the square root of 5,169 over 4. Which separated would mean either x is 7 plus the square root of 5,169 over 4, or x would be equal to 7 minus the square root of 5,169 over 4. Now, square root of 5,169, we've already typed into our calculator, it's about 71.9. That means this value would be negative. And x defines the width. Okay, so we're going to reject that answer. And now we need to figure out what this answer is to the nearest tenth. So what I would do is I would plug in the numerator first, get that answer, and then divide it by 4. So we can go 7 plus the square root of 5,169, hit enter, and now hit divided by 4. So we have 19.723, so x equals 19.723. So rounded to the nearest tenth, x is approximately 19.7. Now they're asking us to find both dimensions, and we're in meters again. Okay, so our dimensions are 19.7 meters by, now we have to do 2 times 19.7 minus 7, plugging into the length, and we'd have 32.4. So here are the dimensions of the field to the nearest tenth. Now this one took some time, and that's going to be the case when we're using the quadratic formula, especially when we have to utilize the calculator. Okay, but this is good review of the quadratic formula and a reminder that not every quadratic equation that we get is factorable or can't be solved by factoring. In that case, we have to use our quadratic formula. If the measure of one side of a square is increased by 5 and the measure of the adjacent side is decreased by 3, the area of the resulting rectangle is 84 square centimeters. Determine the area of the original square. So we have a lot going on in this word problem. So let's start by drawing a square and a rectangle to create the relationship between the two. So we have a square, and then we're turning that into a rectangle. Okay, so in the square, all sides are the same, so we'll call those sides x. And it says one side of the square is increased by 5. Okay, so we'll increase this side by 5. And the adjacent side, which is right here, adjacent, is decreased by 3. So that would mean x minus 3. And we know the area of this rectangle is 84 centimeters squared. Okay, so we'll let x equal the side of the square. We're going to use the rectangle to solve for x. So we can create the equation x plus 5 times x minus 3 equals 84. And we can use this equation to solve for x. So we'll start by distributing. So x squared minus 3x plus 5x minus 15 equals 84. So we have x squared plus 2x minus 99 equals 0. So we need a factor pair of negative 99 that adds to positive 2. So that's going to be x plus 11, x minus 9. So either x plus 11 equals 0 or x minus 9 equals 0. So that means either x equals negative 11 or x equals negative 9. Now, based on how we've defined everything, negative 11 does not make sense. And now what are we looking for? We're looking for the area of the original square. So I really only need to find x. I don't have to find the dimensions of the rectangle. If x is 9, then the area of the square is 9 times 9, which is 81 centimeters squared. So definitely an interesting problem because we started with a square, we transformed the sides to create a rectangle, we know information about that rectangle, and then we have to work our way back to the original square. Okay, but if we visualize it and break it down piece by piece, really no more difficult than some of the earlier questions in the video. The base of a triangle is 1 unit less than twice the altitude. If the area of the triangle is 95 square units, find the measurement of the base and altitude. So let's draw a triangle. And here we have the altitude. So the base of a triangle is 1 unit less than twice the altitude. So if we define x to be the altitude, then 2x minus 1 is the length of the base. So we'll create our let statement. So we'll let x define the altitude, and then 2x minus 1 will define the length of the base. They tell us the area of the triangle is 95 square units. So the area of a triangle is 1/2 base times height. So we have 1/2 times the base times the height, and that's 95. So let's start by multiplying both sides of the equation by 2, so we don't have any fractions. So now we're going to have 2x minus 1 times x, which is going to be 190. We can distribute the x, so 2x squared minus x equals 190. So we'll have 2x squared minus x minus 190 equals 0. We have a quadratic, so the equation has to be equal to 0 in order for us to solve. So we can do this by grouping to review that method. So 2 times negative 190 is negative 380. So we need a factor pair of negative 380 that adds to negative 1. So what do we got? Negative 19 and 20, or the other way, negative 20 and 19. So we'll have 2x squared minus 20x plus 19x minus 190 equals 0. So we'll group the first two terms together, second two terms together. GCF of 2x, we're left with x minus 10. GCF of 19, x minus 10 equals 0. We can factor out x minus 10. We're left with 2x plus 19. So now that we have our factors, use the zero product property. So either x minus 10 equals 0 or 2x plus 19 equals 0. So either x equals 10 or x equals negative 19 over 2. Now x defines the altitude, so it doesn't make sense to define it as a negative value. So x equals 10, and what are we looking for? We're looking for both the base and the height, or the altitude. And we're just dealing with units here. Okay, so the altitude is 10 units, and the base is 2 times 10 minus 1, so 20 minus 1, which is 19. So the base is 19 units. So there we have the dimensions of this particular triangle. The legs of a right triangle have lengths which are consecutive even integers. If the hypotenuse of the triangle is 10 feet, find the length of each leg of the right triangle. Okay, so we have a right triangle with a hypotenuse of 10, and the legs are consecutive even integers. So if I define one leg to be x, the other leg is x plus 2. So we'll let x be equal to one leg, and x plus 2 is the other leg of the right triangle. Now we need an equation to relate the sides of a right triangle together. Well, if we think back, the Pythagorean theorem states that in a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse. Well, that's perfect. We have an a, we have a b, and we have a c. So that's going to be how we're going to define our equation. So we have x squared plus x plus 2 squared equals 10 squared. Now, careful with the x plus 2 squared. As a reminder, off to the side, that's x plus 2 times x plus 2. So we're going to have x squared plus 2x plus 2x plus 4 equals 100. We do have a quadratic equation, so we'll combine our like terms. So 2x squared plus 4x, and I'll move the 100 over, so minus 96 equals 0. Notice that there's a greatest common factor of 2, so x squared plus 2x minus 48 equals 0. So we need a factor pair of negative 48 that adds to positive 2. So it's going to be plus 8 and minus 6. Now we set each factor equal to 0. So we can set 2 equal to 0. And then x plus 8 equals 0. Or x minus 6 equals 0. So this is going to give us x equals negative 8. This will give us x equals 6. Well, 2 equals 0 is not true. X equals negative 8 is a good answer, but based on the context of this problem, we don't want to use that. We can't have a negative side of a right triangle. So x equals 6 is our solution. And it says find the length of each leg. and we're talking in feet. So one leg is 6 feet. The other leg is x plus 2, which is 8 feet. Last one. If the length of one side of a square is doubled and the adjacent side is increased by 2, the resulting rectangle has an area that is 3 times the area of the original square. Find the length of the side of the square. So similar to a question we did a few examples ago, but they're changing it up where the area of the rectangle is now related to the area of the square. Okay, so let's draw this out. So we have a square. Probably could draw a better square. We have a square, and we have a rectangle. Okay, so we'll define x to be the side of the square. So one side is doubled, so we'll say that side's 2x. The other side's increased by 2, so x plus 2. So we'll let x be equal to the side of the square. Now it says that the resulting rectangle has an area that is 3 times the area of the original square. Well, the area of the square is x squared, and the area of the rectangle is 2x times x plus 2. And the area of the rectangle is 3 times the area of the original square. So we can set up an equation, and we can say 3 times the area of the square is equal to the area of the rectangle. So we can distribute the 2x, so we'd have 3x squared equals 2x squared plus 4x. Now it's quadratic, so all terms need to be on one side, so it's equal to 0. So we'll subtract 2x squared, we have x squared. Subtract 4x, so minus 4x equals 0. We can factor using the greatest common factor method. So we have x times x minus 4 equals 0, which means either x equals 0 or x minus 4 equals 0, x equals 4. Now, x equals 0 doesn't make sense in this problem. That would mean the square has side length of 0. We wouldn't actually have a square. Now, find the length of the side of the square. So, x equals 4. X was the side length of the square. So, 4 units. They don't give us a measurement. Okay, so what these word problems required is a little bit of an understanding of some basic geometry, right? Mainly rectangles, but we worked in a few squares. We worked in some triangles, some right triangles with the Pythagorean theorem, and then an ability to solve quadratic equations, whether that was by factoring or with the quadratic formula. In that case, we had to round our answer. So now's the time where you need to go and practice on your own. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.